Hello there. Now we will continue our discussion from lecture 3 to lecture 4. Let us pick up some points from here and try to realize them with examples. So it says pointers are capable of storing addresses. The domain of pointer depends on its type. All that we will see in detail. So by the time I type this code, I would request all of you to go through what has been copy pasted above. So I will have printf now. So we know that suppose if I declare int a and print the value of a, I use %d because I am printing an integer. Save this code. Okay, so now when I run this code, I should be able to display the value of a, which is 0. Now why it is 0? Because it is in an uninitialized global segment and it goes to, then it gets initialized to 0, because all global declarations are, if not initialized, will be initialized to 0. Now suddenly what happens is, when I do a, means a is allocated a memory location. The memory location is addressable. The type of memory location is capable of, or is an address which can store an integer, Now if you look at the domain of a, the domain of a will be integer. The range of a will be a set which will consist of all negative numbers to 0 to positive. When I say all, depends on the range that is supported. Okay. So above, the type of memory location is an address which can store whatever, which I can even conclude that a has a memory address. So when I say a has a memory address, I have to find out what is the memory address of a. To find out the memory address of a, I will use the ampersand of a. And for printing any memory address, my format specifier is %p. So why I should give an ampersand of A and why I should give an A? When I give an A, it directly gives me the content of A, means the address decays. And when I give AND of A, it gives me the address of A. So let us run this. So it now prints me an address of A, which is nothing but 6040104C. Means this address is now labeled as A. So whenever I refer to A, I am referring to the content of A. Whenever referring to AND of A, I am referring to address of A. Let us extrapolate the same thing to an integer pointer now. Okay. So I will just copy paste, and if I have to do the integer pointer, I will give the label to the integer pointer, and to differentiate between an integer and integer pointer, I give a star because that's the syntax. Now let us go back and do the same thing again. APTR is allocated memory. The memory location is addressable. Now the type of memory location in this case is an address which can store an address of an integer, of a integer location, we can say that or you can also say it can store an address whose content will always be an integer. If you compare both the paragraphs, it can store an integer, it can store an address of an integer, or it can store an address whose content will always be an integer. So that's what it means. Which means now a pointer like A also has a memory address. Now the domain of A pointer will be what? Will be set of integer addresses. Will be okay. The domain of will be integer address. The range will be set of integer addresses including a null or a nil address. Okay. And null and nil is common for all domains and all ranges. Okay. Alright. So similarly, we will just do this. I will copy this statement and paste this statement. So what will I do? So if you look at the difference, the range of A is a set of integer nil or a null, means integer address. Okay, it is a set of integer address. So the value of A pointer will be nothing but an address and that I indicate by A pointers. Exactly same. Why it is an integer address? Because it is an integer pointer. Why it is an integer? Because it is an integer type. That's what it actually means. Now A pointer will also have an address, okay, which is again A pointer. Now in this case I will give APTR. Now let me go back which means now the type of memory location is address, so the memory is addressable. This is what I mean by, we will see what is the meaning of an addressable memory location. Before we look at the addressable memory location, let us look at the output of this. So I save this code and try and run this code. Okay, now I made as APTR, which we do not have, so it is just APTR. Sorry about it. So let me clear this. It's nice to sometime introduce errors. So A dot out. So now if you see, the value of A is 0 because it is an uninitialized value. The address of A is again 601058, and address of APTR is nil, and address of value of APTR is nil, and address of APTR is 6015. So I think I made mistake here. Address of, this is value of, just to get the display output properly. Value of, this is value of, this is address of. Alright, let me save this. Let us get a clean understanding of the output. Alright, so the value of A is 0 because it is uninitialized. It has also an address. The value of A pointer is nil because I can't give a 0 because the domain of A pointer is integer address, and address of A pointer is 0x601050. Let us go and look at the addressable aspect of something. What is the meaning of that? So since A has an address, it is addressable. That I will assign it to AND of A. Means if it is addressable, A means it can be referred by an integer pointer. That's what it actually means. It can be referred by. Now this fellow integer pointer, it can be referred by pointer to integer, pointer to an integer. Okay, that's how it gets extrapolated. So let us now look at the output. If you look at the output now, the value of A is 0. Now the address of A is 1050. Now our value of A pointer is the address of A. Correct? I think you got the drift there. And address of APTR is some address. Alright. So let me go back and do the same thing again. I will copy and extrapolate this further. Okay. So suppose if I have an address integer to an integer pointer, I'll call it as APTR, and that I'll assign it to nothing. Now again what I'll do, APTR is allocated a memory location. The memory location is addressable. The type of memory location is an address of an address. It is an address of an address, is an address of an address is an address of an address which can store integer. See, this is how it is. I am just trying to extrapolate it. Now the domain of APTR will be an address of integer addresses. It's not address of integers, address of integer addresses. Solve a problem. It will be address of an integer address. This is already there. So it continues. So what do I get here is the range can be set of address of integer addresses. address of integer addresses. Okay, which can be null. Null can also be there. Now it can be referred, this again can be referred by pointer to a pointer to a pointer. So that's how it actually grows, right? So let me go back and redo the same thing. Just copy this. So what will be my value of APTR? The value of AAPTR now is just AAPTR, which is again an address. The address of AAPTR is an address of AAPTR. Okay, so if you run this code, you could have by now you could have guessed what the output may be. So it is 0. The address of A is 1060. The value of A pointer is address of A, which is 1060. The address of A pointer is 0x1048. Now the address of AAPTR is nil because we have not assigned anything. But the address of AAPTR will also have an address, so that is 1058. So let us again go back and do the same thing what we did earlier. I will now make this fellow refer to address of APTR. Okay, refer to address of APTR. So now what will be my value of APTR? My value of APTR should be the address of APTR. Okay, so let me go back and run this code. If you see, the value of A is 0, the address is 105C, the value of APTR is 105C because it is the address of A, the address of APTR is 601048, the value of APTR is the address of A, and the address of A is something. Correct? What does this actually mean? The moment I put one more aspect is the value of APTR is always a percentage P because it is a pointer to an integer, but the dereferenced value of APTR will be an integer because it is referring to an integer, so which I will indicate it as star APTR. Okay, so let us see what will happen. So when I do this and do the A dot out, so my value of A is 0, address of A is 105C, value of APTR is 60105C, dereferenced value of APTR now is 0, which means it is the dereference, where dereference means the value of APTR is 60105C, dereference means I will go to 60105C's content, which is 0. That's why it is 0. Similarly, I will make a change here now. I will copy this. Now what will be my dereferenced value of AAPTR? Now here the dereferenced value of AAPTR is percentage %D, but the dereferenced value of AAPTR is again an address because it is the address of APTR. Correct? So if you see this output, one second, I think I made it APTR, I should make it as AAPTR. So okay, if you now look at the address of A is this we have understood. Now the address of APTR is this one. The value of APTR when I dereference is nothing but the address of APTR. Initially it was 0, now it is the address of APTR. Okay, so I'm sorry, if you look at the value of APTR, was there any confused? Dereference value of APTR should be the address of, correct. Okay, now let me go back and see the code. Now the value of APTR is 10. The value of AAPTR will be some value. Okay, the value of AAPTR will be, what is some value? The value of AAPTR will be address of APTR, correct? And the dereference value will be the content of that APTR. So for example, if I go and look at this code, so the address of A is 015C, the value of APTR is the address of A. So dereference value of APTR is 0. The address of APTR is 60105T, which is the value of AAPTR, which is correct. So the dereference value of APTR will be 01x5C, correct? Now if I want to again find the, means I have one more opportunity to dereference even that. So if I now do the dereference value, dereference of dereferenced value, I cannot further dereference an integer constant. Now it is nothing but the percentage D, which is nothing but star APTR, double dereference. Let us see what will happen. So what does it actually mean now? The value of APTR is A, the value of A is 0, the address of A is 0150C, which is the value of APTR. So the dereference value of APTR is dereferencing 0x105C, which is nothing but 0. The address of APTR is 601048, which is the value of APTR. Now the dereference of APTR will give me the dereference value of 601048, which is 601005C, and the double dereference of 601048 is 60105C, first reference dereference. The second dereference is the content, which is nothing but 0. Alright, so if I want to now really understand, let me change the value of A now, and I will make the value of A as 9000. Okay, and now let me run this code. So A is 9000, dereference value of A pointer is 9000, double dereference value of A pointer is also 9000. Okay, now if you, so that is what it actually means. Now somewhere we have seen that everywhere whenever I say address, it gives me it tells me percentage P. It kind of masks the concept of an address. Now there is this difference between the size of an address and the domain of an address. The domain of an address we have already seen now. But what is the size of an address? So when I say size of an address, let me see what is the size of an integer address. So an integer address is, for example, percentage so address of size of, let's say size of and of A is nothing but percentage let and. I don't know what size of is, so we will look at percentage D only. So we will just look at size of and of A. Okay, and let us see what is the size of and of A. So when we run this code, so let us ignore the warning there. So it says 8, right, which means it is 8 bytes. Size of and of A is 8 bytes, which is an integer address, right? So what is the size of a pointer to an integer? Okay, so a pointer to an integer, let us see, which is also an address, right? So a pointer to an integer, which is int star, I'll just make it as int star. Since we have made int star, we should also look at int star, int star star. Okay, we'll make it an int star star, and let us see all of that together. So let me save this. Not worry about the warnings. It says 888, so which means the size of and A is same, the size of int star is same, the size of int star star is same. So we can generalize that size of int star 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 will be same, which means the size is 8 bytes. even if the size is 8 bytes, which is common, the domain and range will be different. Alright, number one. Then one more aspect with respect to the size 8. On this machine, it is showing 8. It's an implementation dependency or integration dependent. Or maybe on some of the compilers like maybe Borland C or Turbo C running on Windows or other machine may show the size of an address to be 4. Okay, that's fine. But if you look at this, we get some hint wherein the size of AND of A and the size of int star looks like to be same. So do we have a pattern here? For example, let me take printf, the value of A is A. Instead of saying A directly, can I say, if I say AND of A, it prints the address, I'll dereference the AND of A. So when I dereference an address, what I should get? I should get its value, isn't it? So AND of A is whatever is the address of A, and I dereference that. So what should be the value? It should be A, right? Technically. So let us see if this is possible. Will not worry about the error. See, it is 9000. Because when I say star of AND of A, the AND of A is what? 0x. So star of this is 9000. Okay. These addresses you cannot directly take and manipulate because we don't know the address. You can GCC can show that you can do that, but it is actually not legal, right? Now suddenly you get very motivated and you want to do something like this. So is it commutative? Can I use the order matter? So if I do and star, so what does that now actually mean? You are now probably trying to get a dereferenced value of A and the address of dereferenced value. Now if you get a dereferenced value of A, what is the problem? A is not a pointer. A is a constant, so you can't dereference a constant, right? There is no further dereferencing, right? So if you do something like this, maybe I should get a syntax error, right? Alright, so I get a syntax error, right? Suddenly we may look at one more option. What if I take a APTR, correct? And I do the dereferenced value of APTR, which is %d, and if I get the AND of that, so what is the dereferenced value of APTR? The dereferenced value of APTR is again what? A. So it is equivalent to my AND of star of A, exactly same error that I get. Then you may ask me, sir, what happens if I do star and star? Okay, now if you do star and star, it worked because when you do star of and together, it gets cancelled. We have seen previously. Now it becomes star of APTR, which is very legal. Okay, this is just an observation, right? So I know for a video like this, you have a lot of information that is a part of this video. But if you go through my video slowly, understand it better, okay, you will be able to appreciate. But caution is, whenever I am doing these videos are just for reference. As far as possible, I will be logically correct and maybe technically accurate. Maybe there is a possibility that I would have just goofed up here and there. So the person who is watching the video, please help me saying that if I have understood a concept totally wrong, maybe, which I don't wish to, or maybe you have a better way of explanation, we can share it with me. My email ID is nitinpujari@gmail.com. So that will help me to make the videos better. These videos are free. There is no paid or monetization associated with this. So this is for all the stakeholders who want to understand the subject better. So thank you very much, and see you in the next set of videos. Thank you.